Hello, my name is Andrew Edson, and our team worked on spam email classification throughout the course of this semester. What is the problem? Well, have you ever noticed that email inboxes grow increasingly more frustrating every day? More spam seems to be getting through, tons of sales, tons of ads, just a ton of junk, but for some reason it goes into your inbox. And then when you need to find important information, the important information gets marked as junk. That is really annoying, and that is the problem we want to solve. Also, the classification seems very random. It seems like it's marking this over here, and you, as the user, don't know why. So, our goal was to have a machine learning model that made classifications and then generated reports onto why they marked certain emails where. What was our machine learning solution? Well, first off, we started with training and evaluating multiple models to find a winner. These models consisted of standard vector machine, logistic regression, random forest, and neural network. And then from there, once we found a winner, which we'll explain on later in the presentation, we used tools available to us, such as XAI packages and large language models, to generate human readable model explanations. What was our implementation? So, this was kind of the high level implementation of our project. We started off with a raw email data set. We pre processed the data, we balanced the classes so we have the same split of spam and ham. We cleaned the text. Then we did our train test split, which was a standard 80-20 train test split. And then we did some feature engineering for the more, I would say, standard models. We used TF-IDF. And then for the neural network, we used a tokenizer. Then we trained our four models. We saved those models. And then we loaded the models and evaluated the models and then compared the metrics. You can look in our code base. We have this documented in our code base with all the code. And there is a notebook that loads and evaluates all the models and then we use the explainability packages, Lime and Shap, to feed into a large language model API in order to generate human readable documentation of our model output.
So to tackle the main problem of our project, as well as some of the key questions we mentioned in our project report, we experimented with a couple of models, some of them being very traditional and one being more advanced. First, we introduced our new school contender, a TensorFlow LSTM model. This is a deep learning network designed to understand the sequence and context of words in an email. We thought this would be perfect for catching nuanced spam. The surprise is that it actually performed worse compared to the other models. This advanced model achieved about 95.8% accuracy, lower than our simpler models. On top of that, it was 10 times slower to train, taking nearly 15 seconds. Next, we looked at our old school workhouse, the logistic regression model. This model focuses on recognizing spam based on important keywords found in emails. The result is that it was fast training in just over a second. It delivered a strong 96.5 accuracy and was excellent at identifying spam. However, there was one major issue with it. It sometimes flagged legitimate emails as spam, which is a big problem for users. So far, what we learned is that for spam detection, which itself is a task largely driven by obvious keywords, the simpler models often win.
Our second best model was the random forest, which is a decision tree based model, which uses multiple decision trees that get trained on random parts of the data. So one might be trained on words with maybe some spelling mistakes. Maybe one's looking for words that imply a sense of urgency, like buy now, act now, limited time. And in our instance, we had 100 different decision trees. So over those decision trees, they all make a prediction based off the same input. And then you take the average of all those predictions, and that tells you whether it's, in our case, spam or not. This did really well for us. It's our second best with a 97% accuracy, which falls just behind support vector machine, or SVM. These are also great at classification. And we used term frequency / inverse document frequency, which takes in the number of occurrences of a word, so like the, by, act, now, and those get weighted. And a way to imagine how SVMs, or support vector machines, work is if you plot those points, and for, again, we're using term frequency, we try to draw a line, a boundary line, that separates the two. So on this graph here, if we imagine the blue dot says good emails and the red says spam, we can see that they kind of fall into two distinct categories or groups. And so we want to try to draw a line to maximize between those, so that when we go into production, we can then just take the input email, put it on the plot, and if it falls on the left-hand side of the boundary line in this case, then it is a good email, and if it falls on the right-hand side, then it's a bad email. We could try to change from a linear kernel, which is the boundary line, to like a polynomial, maybe try to get some more accuracy. However, considering it scored almost exactly 99% accuracy, there's not really a reason to. This ended up being our best model, so there's not really much reason to switch to from a linear kernel.
So now I'll briefly walk through how our program handles a new email. First, we load our saved SVM model and the TF-IDF vectorizer from disk. Then a raw email comes in as plain text. We pre-process it by cleaning the text, removing punctuation, lowercasing, and so on. Next, we vectorize the cleaned email using the TF-IDF transformer, turning it into a numerical feature vector that our model understands. We pass that feature vector into the SVM, which outputs a prediction, spam or not spam. We then map that to a human-readable label like spam or not spam and display it. Finally, we send the same input through Lime to generate an explanation. Lime highlights which words increase the probability of spam and which words pulled it back towards ham. So the full pipeline, just to break it down, is load model, pre-process, vectorize, predict, and then explain the decision. So here's how our model is compared overall. The SVM with the linear kernel achieved the highest accuracy at 99%, making it our best model by far. Logistic regression and the random forest both performed very well at about 97%, so they are strong classical baselines. The LSTM model came in slightly lower at 96%, which shows that the deep learning wasn't automatically better here, especially given the data size and the complexity of the training. To understand why the models made the decisions, we used Lime, SHAP, and LLM generated explanations. These tools helped us to see which words and patterns pushed emails towards spam versus ham. As far as future work goes, first we'd like to deploy this system as either a web app or like a REST API, so it can classify emails in real time and provide explanations to users. We think that'd be pretty cool. Second, on the modeling side, we want to improve the deep learning approach by testing transformer-based architectures. We also want more advanced explainability, such as dashboards that show global trends across the whole data set, not just one email at a time. Another idea is to add an active learning loop where the system learns from the user feedback, like when someone marks an email as spam or not spam, just to continuously refine the model. Finally, our long-term goal is integration with email clients. So this model could perform live filtering and show explanations inside the inbox. And obviously this would make spam handling more transparent and a lot more controllable.